This video is an add-on to a previous video, which was for lesson 2.8, eliminating fractions and decimals in equations. And the reason I didn't get to it last time is I was just kind of on a time crunch. So I got to this last problem, I had to leave. So I didn't quite get that finished. So coming back to it now though, so hopefully if you're watching this, if you tried earlier, it wouldn't have been here, of course, but hopefully some of you can still find this. So this is number 28 because your assignment asked you to do number 29, but I didn't have an example like it. So that's what I'm doing. This is number 28 on page 88 from your assignment. And these, by the way, number 29 is actually probably easier than number 21 if you've already done that one. There's less work involved, but you still kind of need to know there's something a little different about how you solve it. But once you see it, hopefully you recognize it actually seems a little bit easier. So this is number 28 again. So I've got t plus 1 divided by 2 is equal to t, or 2t minus 3 divided by 6. Now, number 21 and 20, which I think was in a video, or maybe it was 22, you need to find a common denominator. And you don't really necessarily need to do it on both sides, just on one side or the other, you need a common denominator so you could combine the different terms. Now, in this case, and like number 28 and number 29, you're going to find a common denominator on both sides. So what we're going to do is we can say, well, this one is halves, this one is 6. So there's actually a couple ways we could do this, but I'm going to show it just finding a common denominator. This one is already 6. This one is 2. Well, I want to make this 6 as well. So I'm going to take all of this, and this, all times 3. And all I'm doing is I'm just renaming the fraction so that it has a common denominator. So in these, there is distributing going on, so we need to be careful there. So here I'm just going to get 3 times t, and 3 times 1 should give me 3t plus 3. And in my numerator, 3 times 2 should give me 6. So now I have the same denominators on both sides of the equation. And what I can do now is, I don't really want that denominator to be there, so I can just take both sides times 6. And as long as I do it to both sides, I can do that because it's not changing the values, but it is going to make this a little bit simpler. And I might just think of it as 6 over 1 because I'm not multiplying everything times 6. That would just be rename it again. So cross those out. So those factor out. So now I'm just left with 3t plus 3. I am using t because that's what they use, but I think I've said on previous occasions, I don't really personally like to use t's because they sometimes look like plus signs. So even if the problem has t's in it, if you choose to use n or some other variable instead, you are welcome to do that. But anyway, all that I've done is by finding the same denominator and renaming, I could then multiply both numbers by that denominator. So now it just looks like equations we've done a bunch of times. Oh, and this is a 2t. So I'm going to take away, so I had a 2t minus 3. I'm going to take away 2t from both sides. So here, 2t minus 2t, this is gone. I'm just left with that negative 3. Keep that sign with it. You might think, well, I thought that was a minus 3. Well, minus 3 and a negative 3 end up working kind of the same mathematically. So you can just write in minus 3 or a negative 3. 3t minus 2t will be 1t, or you can think of that as just t plus the 3. I'm just bringing that 3 down. One step to go. I want t by itself. Right now it has a 3 added to it. I'll undo that by subtracting 3 or adding a negative 3, either way. So here, these are going to cancel out. I'm just left with t. And negative 3 minus 3 should give me negative 6. And just a reminder, you can always check your answer. If t is negative 6, well, let's see. Negative 6 plus 1 would be negative 5 over 2. I'm just going to write that over here. Here, I'm just checking. I said t is negative 6. So 2 times negative 6 should be a negative 12. Negative 12 minus 3 is negative 15 over 6. Well, both 15 and 6 are divisible by 3. If I divide those both by 3, I will get 5 halves, which is the same as what I had there. So checking work doesn't take very long. Whatever you found for t, just put in for the t's in each side and check it. So that's one way to do it. There is another way, and I will show it You don't necessarily need to know how to do both ways, but sometimes some people like one way better than the other. So what I'm going to do for the other way, I'll clear this, is you can also do, if you have fractions shown as being equal to each other, and you could really think of these as being fractions, and I'm just going to do a quick example. So let's say I could say 2/3 is equal to 4/6. So when that's true, what should happen is that cross products will be equal. 6 times 2 is 12. 3 times 4 is 12. Now we can do the same thing with this. It's not going to be quite as simple because they've got bigger numbers or bigger values, but I can still do the same thing. I can do this times this, which should be, so 6 times t plus 1. So I distribute that to both, not just one. So I could multiply those together and get 6t plus 6. And it doesn't matter if I put that on the left side or the right side of the equation. And I'm going to do the other ones. Cross products, 2 times 2t minus 3. And that 2 gets multiplied by both, not just the first one. So 2 times 2t should be 4t. 2 times a -3 will give us a -6 or -6. And now from this point, now I can start solving. I can subtract 4t from both sides. Here they're gone. So I have 2t plus 6 equals a -6. I'll get rid of this 6 on the left side. It was plus 6. I'm going to subtract 6 from both sides. On the left side, I'm just left with 2t. After these have canceled, -6 minus 6 is -12. Right now, t is being multiplied by 2. Divide both sides by 2 to undo that. 2 divided 2 is 1. 1t is just t. -12 divided by 2 is -6, which is the same answer we came up with before. So whether you do it as a cross products strategy or you find a common denominator, either way can work. It's just kind of a matter of which one do you think works best for you or is going to make the most sense to you. So hopefully this is number 28, but 29 will work in a similar way. I know the numbers are maybe a little bit messier, but it's the same steps and you can use either of these two methods to do that. And there's probably other methods as well that I didn't show, but those are two you could try.